So we are starting here, last article, we'll say last part of the PDE here. Yes, the topic is completely mathematical. None of the application of a PDE is included in our syllabus. Okay. So we're not going that right now. So last part is our first order nonlinear PDE. In first order nonlinear PDE, we have total 4 cases. Along with that 4 cases, that case 1 to 4, we have one more as a Charpit's method. Generally, as per the old question paper pattern, Charpit's method is very important. The questions are coming on Charpit's method in each question paper. Each and every question paper contains one question on a Charpit's method. And there are mainly 3 solved example in the book, and that's only coming. We'll come to that later on. But right now, yes, today we are going to finish these 4 cases, the 4 cases of nonlinear PD, that case 1 to 4 there. If you observe, we are given z, and that z is a function of xy, and then we have that p, q, r, s, t. P, q are the first order partial derivatives, and r, s, t are the second order. So right now, the maximum variables which can be present in the differential equations are x, y, z, p, and q. Out of that, if only PQ are present, we use case 1, method 1. If only PQZ are there, we use a method 2 to solve it. When XP and YQ are present, then we use method 3. Okay, XP and YQ. Okay, so see, if only PQ should be there, then we use method 1. Then PQZ should be there only, method 2. XP and YQ should be there, and that should be separated on the two sides of the equation. Then we use a method 3. And last one is a Clairaut's form. It is one of the simplest method whose answer can be written in a single line only. So this question, if it come in the exam, it will come maximum for 2 marks. Okay, the weightage for this question can be a maximum 2 marks there, because it's so simple, one line answer is there. Okay, so we'll come to these cases one by one. We are learning first order PDE, so first order only PQ will be present, RST will not be present anywhere now. Okay, so higher order PDE are solved by the method of the CF plus PI. Now we are in first order. First order, we have these different cases there. Okay. So case number 1, we already seen f of PQ. Okay, the case 1 is f of PQ. If only P and Q are present, then we say we will say that z equal to ax plus by plus c is a solution where f of ab is a 0. F of ab is a 0 there. So from this relation, we can eliminate one of the constant from the solution, because as it is a first order PDE, its a solution should contain one arbitrary function or two arbitrary constant. Right now there are 3 arbitrary constant, a, b, and c. So one should be eliminated, and to eliminate it, we use this relation f of ab equal to 0. So we'll see the example, then it becomes more clear. So see the question. Question is like this: solve p minus q equal to 1. Solve p minus. Only p and q are present. You will observe only p, q are present. So in a solution, we will say, therefore the solution is a z equal to ax plus by plus c, where f of ab is a 0. Now, how to get that relation? Just replace p by a and q by b, and we get that f of ab as a 0. So if we replace p by a and q by b in the given equation, we get a minus b is equal to 1. A minus b equal to 1. So from this equation, we can get the value of a as a b plus 1. If we use this value in this equation, we get z equal to the value of a we replace as a b plus 1 of x plus by plus c, and this is the final answer. This is the partial differential equation corresponding to, this is a partial differential equation corresponding to, sorry, this is the solution of the given partial differential equation. My mistake. Or reverse way also you can cross check. If you calculate dou z by dou x and dou z by dou y, you will get p minus q is equal to 1. You will get that corresponding differential equation only, p minus q equal to 1. Right now, I obtained the value of a in terms of b. If some other student get, or some other person get the value of a b in terms of a, like b is equal to a minus 1, and suppose he writes the answer as z equal to ax plus a minus 1 y plus c, that is also correct. So z equal to ax plus a minus 1y plus c. This is also the correct answer. So you can write any one of the answer. Either you can eliminate a or b using the relation f of ab equal to 0, and that becomes our final answer. So it is one of the again simple case. It's not so difficult. So I will show the answer here. The answer is on the screen. You'll observe the given equation is p minus q equal to 1. So z equal to ax plus by plus c should be a solution where a minus b is 1, and we get that answer. Okay. So this question also can come for 2 marks, not more than for 2 marks there. Okay. The 2-mark question only. Any doubt in the case 1? Is there any doubt? Anyone have any doubt in the case 1? Okay, a few more questions. Actually, this is one of the exercise 17.4 from your textbook. Now I want first identification from these 8 examples, question number 1 to question 8. Tell me which are the questions of the type 1? Which are the questions are of the type 1 there? Case 1 there. No answer. Quick.
1 and 2.
1 and 2. Very good. 1 and 2. Okay, yes, both of you are correct. Only 1 and 2 are of the required form. You will observe this is a p plus q equal to pq, p square plus q square equal to 1. So there only pq are present. But in other equation, here z is present, here z is a present. Okay, here xp, xy are present, xy are present. So none of the other question is of the type 1. So only first and second are the type 1. So answer can be written very quickly. First answer you can write z equal to ax plus by plus c, where now you have to replace p by a and q by b. We get a plus b is equal to ab. Okay, if we replace p by a and q by b, a plus b is equal to ab. One relation we get. From this relation, yes, we have to find the value of a or b. So to get the value of a, I take a minus ab is equal to minus b, because this b taken on that side, ab was taken on left hand side. So a into 1 minus b is equal to minus b. So what is the value of a? Yes, anyone?
b upon b minus 1.
Yes, b upon b minus 1. Very good. X plus by plus c, and this is the final answer. This is the general solution or a complete solution of this differential equation. P plus q is equal to pq have a solution as b upon b minus 1 of x plus by plus c there. One more important thing that I want to tell you for the previous question, actually, the example that we solved, let I erase this part. The example which already we completed, p minus q equal to 1. Okay, and we got a solution at z equal to a minus b equal to 1. So a is a b plus 1. So b plus 1 y. So b ax plus by plus c. So value of a is. So this is a solution we observed by type 1 or case 1 there. But if you observe this differential equation, this is also in the form of pp plus qq is equal to r, where small p and small q are dou z by dou x and dou z by dou y. Capital PQR should be function of xyz. In this case, capital P is 1, capital Q is minus 1, capital R is 1. So we get Lagrange's auxiliary equation as dx upon P, dy upon Q, and dz upon R. And this also gives us one solution, like from first two ratio we get x integrating x minus y plus c, or this gives us x plus y equal to c1. Okay. Similarly, from last two ratio we get y plus z equal to c2, something like that. And then we can write the answer phi of u comma v equal to 0 or u equal to phi v. So I will say u is x plus y is equal to phi of v, so phi of y plus z. So this is the answer. This is actually the answer by Lagrange's. Now you will clearly observe the answers looks totally different. The answers look totally different. Yes, they are different answers, but the corresponding PD is the same. Okay. I will say this solution contains one arbitrary function, and this solution contains two arbitrary constant. Okay, so the important thing that you should note down here is many times many of the questions can be solved by more than one method. I will repeat my statement because it's important. Sometimes you have the question in your mind that this equation fits in two different forms, so that happens there, that happens. So some questions are there which can be solved by more than one method. Then choice is your. Okay, you have the choice, you can do by any of the way. The best thing is you should go by a simple method, whatever the simple method you feel. Is it clear? Is it clear?
Yes, sir.
Okay, good. So that about a type 1. Let me move to the type 2 or case 2 here. Case 2, now here is a case 2, just focus only on the second case here, PQZ. If the equation contains only PQZ, then we use this substitution, u is equal to x plus ay. So what happens generally, this z will become a function of u, and this u is a function of x and y. Why u is a function of x plus y? Because u is x plus ay. Okay, so we are assuming z is a function of u, and then u is a function of xy, and because of that, because of this substitution, what happens? Whatever the PDE we have, in terms of PQZ, that converted to the ODE, ordinary differential equation, and then in ODE you already learned a variable separable method that we can use it. Just separate the two variables on two sides of equation, integrate, and we get the answer. Now, why this? How this happened? First thing, you should remember this: u is x plus ay. If u is x plus ay, a plus ay, then the value of that dou z by dou x, or the value of small p we know this is a dou z by dou x. Now we have to go from z to x here to get a dou z by dou x. But in between now, we taken z is a function of u, and then u is a function of xy. So there is a chain rule, and that chain rule become dz by du. Why I am using dz? The reason is it is single variable. Now more than one variable, partial into dou u by dou x, So that's a chain rule. But if you observe the dou u by dou x value, what is the dou u by dou x value here from this expression?
X plus A1.
No, I am asking dou u by dou x. What is the dou u by dou x?
1.
1. So no need to write it. So value of p becomes dz by du. Value of p becomes dz by du because dou u by dou x is 1. And in the case of q, which is a dou z by dou y, we have dz by du into dou u by dou y. And now what is the dou u by dou y?
A.
A. That's a dz by du. So this derivation, no need to write in example. Just you have to remember these three things. When only PQZ are present, put u is equal to x plus ay, and p becomes dz by du and q becomes a dz by du. Okay, so that these three things you have to remember, and replace it, you get ODE. Some other textbook instead of this substitution, this also given, or I'm saying instead of u equal to x plus ay, you can take u is equal to ax plus y. Okay, see here, x plus ay or ax plus y. Both are possible, but if you use this substitution, u equal to ax plus ay, that time your value of a p becomes a dz by du, and value of q become dz by du. Provided you use ax plus ay. But if you use x plus ay, then these are the things. So just remember only one thing. Example can be solved by x plus ay substitution or ax plus y substitution. Both are possible. Just keep only one substitution in mind so that you should not have a confusion. Okay, and you can solve each and every example there. That's all. Come to the question. So question is here on the screen. P into 1 plus q is equal to qz. The first important thing we notice, only PQZ present. Only PQZ are present. So we will start with that our substitution. Let u is equal to x plus ay. let u is equal to x plus ay, then p is equal to dz by du, and q becomes a dz by du. Okay, we are going to replace the values of p and q there. So if you replace p and q values in the given differential equation as a dz by du and a dz by du, so value of p is a dz by du, 1 plus a dz by du is equal to this is a q is a dz by du. Okay, so that's one, and that z as it is. This z is as it is. We'll observe this dz by du gets cancelled, and what we left? We left 1 plus a dz by du is equal to az. We left here actually 1 plus a dz by du is equal to az. Now this 1 is taken on that side, so it become a dz by du is equal to az minus 1. Is it okay? Important thing is we have ODE now. As it is ODE, we are going to write in variable separable form so that integration is possible. So obviously we'll take this du on the other side and terms of z on one side, and we will get the variable separable form as this one. This is variable separable form where a dz upon az minus 1 is there, and other side is du. This is a plus, the constant of integration is written, so you should say plus constant of integration b, or you can say as a c. Okay, anything that is constant of integration there. What is the integration of this side, left hand side? Yes, anyone? What's the integration of
Z minus 1.
log az minus 1? Okay, so log az minus 1, that's the integration of left hand side. Integration of du is u plus b. Resubstitute the value of u. The value of u is here, that we are resubstitute here, and that's the final answer. So this, yeah, this answer should be highlighted. That is our complete solution. This is the required answer there. Log of az minus 1 is equal to x plus ay plus b. That's one. So if you have the doubt, yes, you can ask. So case 1, only PQ are there. In only PQ, we have z equal to ax plus by plus c as a solution where f of ab is a 0. Case 2 is f of pqz. Whenever only pqz are there, we replace u as x plus ay, p by dz by du, q by a dz by du, and we get the answer there. Just integration. At the end, just have to integrate it. So if you complete the writing, tell me. We'll move to one more question on this type.
Sir, wait.
Yes, definitely.
आला तर आता काय म्हणाल.
So completed. Okay, done. So another question on the screen. Q square is equal to z square p square into 1 minus p square. So only pqz are present in the equation. So obviously we can start with let u is equal to x plus ay. Remember, x plus ay you are putting, then the value of q is a dz by du. Okay, so as a is connected with y, so value of q is a dz by du. So if you do the another substitution ax plus y, then value of p is a dz by du, that way. So here it become a dz by du, or a square dz by du bracket square is equal to z square dz by du bracket square into 1 minus dz by du bracket square. Yes, what's the simplification here?
So dz u square get cancel.
Cancel, yes, correct. So this gets cancelled. We left with a square by z square. I will take like this: a square by z square is equal to 1 minus dz by du bracket square. Is that? So dz by du bracket square, dz by du bracket square is equal to 1 minus a square upon z square. So cross multiplying z square minus a square upon z square. So taking square root on both sides, dz by du become root of z square minus a square upon z. So variable separable form. Variable separable will be z upon, sorry, yes, z dz upon root of z square minus a square is equal to du. And now last step is integration. Now what is the integration of LHS? What's the integration of LHS? Yes, anyone? Little louder.
Sir, ln log.
Not ln, not correct. If it is f dash x upon fx only, then ln. Okay, f dash upon f is then ln. So it is f dash is okay, but it is f dash upon root f is there. It is like that. So
Log
not audible.
z square minus a square.
Pardon? Log?
Sir, sir log z square minus a square.
Not correct. Not correct. Denominator is a root there. It's root. So what is the integration of 1 by root x, or what is the integration of f dash x upon root fx? If fx is f dash x upon root fx, or integration of 1 upon root t, integration of 1 by root t, so integration of t raised to minus half, it is a t raised to half upon half. So is that 2 root t? 2 root fx, sorry. So it is a similar that one. So if we want this one, z square minus a square, its derivative is a 2z dz. So if you multiply by 2 and divide by 2, so it becomes 2 root. So 2 gets cancelled. So integrating, the integration is just root of z square minus a square only is equal to u plus c. And don't forget to resubstitute the value of u here, and that's your answer. Are you getting? If you are not getting this step, what you can do is put z square minus a square equal to t. Put z square minus a square as a t, and then 2z dz is a dt. So z dz is a dt by 2, but in integration, that integration of 1 by root t become a 2 root t, so that 2 gets cancelled and you'll have this only. Okay. So I'm written direct. You can do step by step if you want by putting z square minus a square equal to t. Clear? So tell me once you complete it. Are you finished? Are you completed? Done. Okay, good. So in the textbook, this example solved by another substitution. So you will observe instead of x plus ay, it is written y plus ax, and because of that, a similar way you can proceed and similar answer you will get it. So it's not like that. If you use you can do any of the substitution, but accordingly you have to replace it and simplify it. So best is remember only one substitution. U is equal to x plus ay. That's enough there. Come to the case 3 now. Case 3. So in the case 3, we should have xp and yq. Four variables should be present, so it should not, z should not be present. Okay, for case 3, z should not present. Another important thing, that xp and yq should be separated on two sides of the equation. So terms of x and p are collected on LHS, terms of y and q are collected on RHS. So in when this is happening, so we'll take each side is equal to some constant, say the constant k or constant a, anything you can take it. Here a is taken. Now once we take that, we can get the value of p in terms of x and p. We can find out value of a p, we can find out the value of q. From this first expression, we get p in terms of xk. From this last, we get y in terms of q in terms of yk. And once we get that, we can put these values in this equation, dz equal to p dx plus q dy, and integrating, we get the answer. Okay, one important thing I want to tell you about this equation dz. So this equation is considered in case 3 as well as in Charpit's method, because we are assuming that z is a function of xy. Z is a function of xy. Throughout in PD, we are assuming z is a function of xy. So when you take a total derivative, we get dz is equal to dou f by dou x dx plus dou f by dou y dy. So that's a total derivative of z. Okay, where this dou f by dou x is actually a p, because dou f by dou x or dou z by dou x is a p. So dz become p dx plus q dy. So this is the relation that also you have to remember, and that we can use it directly to get the solution. So we'll see the example. It becomes more clear about the case 3 then. So I'll move it to the question. So question is on the screen. P square plus q square equal to x plus y. P square plus q square equal to x plus y. You will observe only p, q, x, y are present. Mainly the z is not present. Whenever z is not present, it can be considered as xp equal to yq form. Xp equal to yq form. So just collect the terms of x and p on one side and terms of y and q on the other side. So this will happen like this. P square minus x is equal to y minus q square. Y minus q square is equal to some constant. Here we are assuming that constant as a. Let it is a. Okay. Now what is the value of p then? Yes, anyone? What should be the value of p in terms of x and a? Find out p and q. What is the value of p? Quick.
Root x plus
Root x plus a, correct. And value of q?
root y minus a.
Correct. Very good. So that's one. So you'll observe the value of p you will get as a root of a plus x, and the value of q we get as a root of y minus a. Now once we get the values of p and q, it is a very simple thing that we have to do it. We have to put it in the differential equation, that is a dz is equal to p dx plus q dy. Okay, so that we get a solution for it. So replacing it in p dx plus q dy, the value of p is a root of a plus x, value of q is a root of y minus a. Now just integrate. What is integration of dz? Integral of dz is obviously a z. What about integration of this first term? Yes. What's the integration of root of a plus x? Yes, no one is able to integrate it.
So 2 by 3 a plus x 3 upon 2.
Okay, 2 by 3 a plus x raised to 3 by 2. Correct. Similarly, 2 by 3 y minus a raised to 3 by 2. That will be the integration of second. Very good. So it is just like integration of x raised to n. So that's the final answer here. So actually we are using integral of x raised to half is x raised to 3 by 2 upon 3 by 2 that way. And this 3 by 2 I taken on left hand side and this kept as a final answer there. So that about case 3 I will say. When xp and yq are separated, we go with this one. I will repeat the steps here. Step number 1.
It will be 3 by 2 z, right?
Pardon, 3 by 2. Yes, correct. It's a 3 by 2 z. Yes, my mistake. Very good. Good observation. It should be 3 by 2 z. 3 by 2 z should be there on left hand side. Correct. Good. So step number 1, we collect terms of p and x on one side, terms of y and q on the other side, assume some constant, find the values of p and q, replace in this equation. So this equation you have to by heart it. You have to remember dz equal to p dx plus q dy. Integrate. We have the answer. That's the important steps here. So tell me once you complete this. If you have doubt, that also you can ask. Yes, completed.
Yes.
So one last question and last method, which is a so simple method there. Come to that. Case 4, and that's a Clairaut's form. So Clairaut's is actually this question is never asked in the exam in last 5-10 years. The reason is only the Clairaut's form looks like this. The differential equation should be in the form of z equal to px plus qy plus f of pq form. And whenever that is the case, just replace p by a and q by b, we get the answer. We get corresponding solution. So if we replace z, p by a and q by b, its a solution is ax plus by plus f of ab. Ax plus by plus f of ab. So I will show you one question here. The question is like this here. So here is the question: solve z equal to px plus qy plus root of 1 plus p square plus q square. What should be answer? So the answer should be z equal to
Ax plus by root over 1 plus a square plus b square.
that's one. So this is a so simple method. It is a corresponding solution is this one, which contains two arbitrary constant. And now if we eliminate two arbitrary constant a and b, we get a is equal to dou z by dou x and b is equal to dou z by dou y, and we get this as answer. Okay, this is a corresponding PDE. So if the question comes, eliminate the arbitrary constant a and b and find the corresponding PDE, then the answer will be this one. But right now we are solving the PDE, and to get a solution, the method says when it is in the form of Clairaut's, this is the observation by the Clairaut's that if the equation is in that form, we get a solution just by replacing p by a and q by b. P by a and q by b. So that about the last case, case number 4. So this is one of the simplest case where the answer is written by a single step only. So it's not so important. Generally the question will not come. Definitely it will not come on it. But if the questions are like MCQs and that things are there, so you may have this as a question as a part of MCQs there. Okay. So any doubt here in any of these four methods?